So I gave x to the power 4 plus 5x square plus 9, okay, is equal to x square plus ax plus b and x square plus cx plus d. This means a 4-degree polynomial is expressed as a product of two quadratic or 2-degree, whatever you say. Yeah. Someone recalls this kind of particular factorization is called Sophie Germain. I am just going to, okay. This is a mathematician named Sophie Germain, and she was lady. She discovered this kind of factorization long back. So the name of this factorization or identity is called Sophie Germain identity. So I'm going to tell you how to factorize this into. We have learned till now middle term splitting. With the middle term, you can't factorize this. X to the power 4 plus 5x square plus 9 is there. So the product is 9 and the sum should be 5. It's not possible. That's what you are facing the difficulty. So what are we going to do in that case? Okay, please listen properly. I'll write x square the whole square, the first term, and the other one as 3 square. Okay, so this is kind of a square, this is kind of a b square. So a square plus b square, a square is this, b square is there. So to make it into whole square, how much is required? Anyone? I want to write this as a plus b the whole square. So how this 3 terms as a plus b the whole square. How much shall I write? Anyone? Yeah. Yes, yes. I need to write 6x square because 2ab will give 6x square. So minus x square. Is it okay? So first 3 terms, this is 2ab I am writing. So first 3 terms is in format of a square x square plus 3 the whole square. Okay, in terms of pre-RMO, this is very, very important. And minus x the whole square. Is it okay for everyone? This is a square, this is b square, and this is 2ab. So 6x square minus x square. Why I wrote minus x square? Because I need to get how much? 5x square. So now this came in format of something like a square minus b square. And all of you know the formula for a square minus b square. Come on guys, what's the formula for a square minus b square? A plus b into a minus b, or a minus b into a plus b, but I'll prefer to write plus first. Okay, into x square plus 3 minus 2x. Okay, so you get x square plus 2x plus 3 into x square minus 2x plus 3.
How did you get 2x?
Not 2x, sorry. That's a printing mistake. Okay. Everyone, please try to do on your own. So I am going to discuss today Sophie Germain. Anyone is having doubt can message. I'll explain again or I'll move to the next problem. Just on Darshan, I'm seeing something you wrote. This is the answer. The last part is the answer. That's it. So A is equal to 1, B is equal to 3, C is equal to -1, D is equal to 3. This A is equal to 1, B is equal to 3, C is equal to -1, D is equal to 3. I assume that everyone understood. I'm going to give a same kind of problem again. Now same, can you factor this into 2 quadratic? Means x square plus ax plus b into x square plus cx plus d. Okay. Come on, everyone. Reply, guys. Yeah, you are correct. Darshan. Let me check the question again. Oh, I think I gave the question wrong. Mm, According to me, sorry, this 7 won't come. Okay. Now please give a try again. Darshan, it was wrong for you. Oh yeah. So what I'm going to do, listen to me how to do this kind of problem. It is x square the whole square, okay, plus 5 the whole square. So you need to write 2ab. This you need to understand very well. So can I write 2 into x square into 5? So you got 10x square. So from 10x square, how much you are going to subtract to get x square? 9x square. So you will get x square plus 5 the whole square minus 3x the whole square. So that is a square minus b square. X square plus 5 plus 3x into x square plus 5 minus 3x. Okay. So can I write again x square plus 3x plus 5 into x square minus 3x plus 5. I hope everyone got it. Can message yes or no? Then I'll move to next problem. Oh yeah, fine. I'm moving to next one. So now another same kind of problem. Okay. So this is 4x square, sorry, 4x to the power 4. A is equal to 3, B is equal, on the previous problem I'm going to discuss, A is equal to 3, B is equal to 5, C is equal to minus 3, D is equal to 5. That's it. So, okay, I'm discussing the new problem. 4x to the power 5 plus 3x square plus 9. In this case, again you have to express. I'm not writing that you have to express this into 2 quadratic. Please do it. I'll give you 5 minutes time. Please do it on your own. Then only you learn Sophie, Germain. I think others, I hope everyone got it. Some of you replied. Can I write 2x? So the process is, first you square the first term and the whichever the two terms are there, a square plus b square. Is it okay? So if I square a square plus b square, I need 2ab, that is 2 into 2x square into 3x square. So that comes how much? 12x square. So how much shall I subtract to get 3x square? So from 12x square, I need to subtract how much? 9x square. So you get 2x square plus 3 the whole square, because a square plus b square plus 2ab is a plus b the whole square minus, can I write this as 3x the whole square? If I can write this as 3x the whole square, now you will get in terms of what? A square minus b square. This term is considered to be a and this term is considered to be b. So a square minus b square is a plus b, x square plus 3 plus 2x, sorry, 3 plus 3x into x square, 2x square plus 3 minus 3x. So you will get 2x square plus 3x. I am rearranging the term, plus 3 into 2x square minus 3x plus 3. Okay. Please make a note. I am going to give another problem. So this is a trick about Sophie Germain. Anyone having doubt, you can message, or otherwise I'll consider that everyone understood. So we learned another, okay, fine. So I'm going ahead. So we learned another thing called Sophie Germain, another problem on Sophie Germain. So I'm going to, so I hope everyone is fine. And now I give a task everyone. Okay. Can you create a Sophie Germain identity on your own? Can you create a Sophie Germain identity? everyone and reply by message. Come on, everyone. No, no, not the proof. I am asking the way I created first two or three identity, the Sophie German means a fourth degree polynomial. Can you create a fourth degree polynomial which can be expressed as a product of 2-degree polynomial? I repeat my question. Okay. The previous problem, how one of them I created. Yeah, someone replies. Correct, I'll write x to the power 4 plus 16. Just hold on. I'll check it. Yeah, Watson tells x to the power 4 plus 16 plus 7x square. This he creates. Anyone else, please? Yeah, anyone? Message me. Yeah, Darshan replies something. But you're not writing in terms of x. It's a polynomial. It should be in terms of x. I want in terms of x. Please, everyone write in terms of x. Navya, I saw you are attending. Text a message how you create one Sophie German. Text me, everyone. So I'll tell you how to create a problem. This was created by Watson. Yeah, someone Navya replies 9x to the power 4 plus 14x square. 14x square plus 25. Okay. Yeah. Yeah. Correct. Go ahead. Anyone else? Darshan? Some Sriniti, you two can create an whomsoever I'll be able to see. I can recall the names. Many others are maybe attending. Yes, yes, come on. Yeah, Darshan. Oh, you write 64x to the power 4. Sorry, I think I would have misunderstood. 64x to the power 4 plus 96x square. Okay, plus 49. Okay. So let us see how to do all these problems. Correct. Okay. First, I'll do what Watson created it. Correct. It's so x square the whole square, what Watson did it, plus 16. Can you make out 16 as 4 square? Okay. So now if you once create it, problem becomes very easy to solve. So this is a square, this is b square, this is a square, this is b square. We need 2ab. So a square and b square. So 2ab will be how much? 2 into x square is 2x square into 4. So 2x square into 4. So that comes to be 8x square. This is how much? 8x square. Okay. Abhishek also creates. Yes, Abhishek. I'll check out. Okay. X to the power 4 plus something here, or 25x square. Okay, plus 625, I think, if I'm not wrong. So 8x square minus how much is 7x square. So x square plus 4 the whole square minus x the whole square. So it is a square minus b square will be a plus b into a minus b. This is what Abhishek taught. Sorry, this is what Watson gave it. So can I rewrite as x square plus x plus 4 into x square minus x plus 4. Okay. I think, hope everyone got it. Next one. 64x to the power 4 plus 96x square plus 49. So I'll write the question. I hope if it's 64x to the power 4 plus 96x square plus 49. What I told that first you need to see a square, and first you need to see this is kind of a square and this is kind of b square. So a 64 is 8x square the whole square, okay, plus 7 the whole square. So how much we need to add over here? 2ab. This is a square, this is b square. So we need to write 2ab. So 2 times of 8x square into 7. Okay. So it comes how much? 8 into 7 is how much? 8 sevens are 56. 56 into 2 is 112. Okay, it is 1112. 1112. So from 1112, how much shall I subtract to get 96? If you have a doubt, what you do here, you write 112 minus 96 is 16. Okay. So this is layman method, but I'm just telling directly what you can subtract it. Okay, is 2, 16x squared. Right. So 1112 minus 16 is, okay, 96x squared. And this is also, you have to create in such a way such that this should be a perfect square. That's the trick. So 8x square plus 7 the x square minus, here 16 is there, that is nothing but 4x square, sorry, 4x the whole square. So again, it came in format of a square minus b square. So I write a square minus b square. Either you write a plus b into a minus b, or a minus b into a plus b, or first I'll prefer plus. So 8x square plus 7 plus 4x into 8x square plus 7 minus 4x. Make a note of it. Please, everyone. Then try the other one, which I hope everyone would have got it. Okay. Fine. So now I'll do one more factorization, then I'll come to tricky problems, the kind of application it comes in pre-RMO. So say I'll choose the last one to do it. Okay, x to the power 4. Okay, x to the power 4. And then how much is there? I think this was given by Abhishek. It was 25, 625. And here he wrote, let us see. And this is given by Abhishek. So You may think this is whole square also, this is also whole square, this is also whole square. There are 3 whole squares are there. Which to prefer? So anyone? This is obviously a square because this will be 2ab. If I write, I'm explaining, if I write 5x the whole square, which is 25x square, so 2ab will be 2 into 5x kind of stuff. So 10x is not there. So the degree 2, this term I cannot assume this to be b square. I repeat, this term I cannot assume to be b square. The reason behind it is that I need to write, if I b square means 5x the whole square. If it is b square, it is 5x the whole square. So to make it into whole square, you need 2ab. So that is 2 into 5x plus into x square. Okay. So there is no such term. There is no such term which contains 10x cube. There is no such term which contains 10x cube. So I'll consider this to be b square. Okay. So this is a square, this is b square. We need 2ab. So 2ab, so 2 into x square into 25, or 2 into 25x square, 2 into 25, 2 into 25 into x square. So 2 into 25 is 50x square. So if I write 50, how much I have to subtract to get 25? So you will get x square plus 25 plus 5x into x square plus 25 minus 5x. I'm going to give you some. Please make a note. This is the last. Now, so I hope you understood the factorization of Sophie Germain. If you have understood, please reply with yes. The basic factorization. Anyone please reply? Yeah, fine. So I'm moving ahead with a pre-RMO RMO kind of problem. How it works, fine? How they give this application of this. But very interestingly, this is not taught in any of the school syllabus. Either it's a CBSE, ICSE, state boards, it's not taught. But in 11th or 12th standard, while doing integration, this application is there. So that time suddenly we just remember it. I call it, we mug up that, but we don't develop the basic thing and then apply it. In 12th standard, in CBSE, in integration, it's given in the CBSE book itself. They don't call it a Sophie Germain identity. In that, application is there. While doing one integration, application is there. So one RMO problem I'm going to discuss first. Now RMO, I hope everyone knows, it's the Regional Mathematics Olympiad. The level to get into the Mathematics Olympiad, it is first you need to write pre-RMO, that's a basic. Then you need to write RMO, then INMO, means Indian National Maths Olympiad, and followed by IMO, that's International Mathematics Olympiad. It's conducted by Government of India, not by any other private body. So I'm going to discuss one. n to the power 4 plus 4 to the power n. Okay, where n is given greater than 1. So it's your wish, you can attend the school online. Okay,
Sir,
no
we
issue.
should prove that this is always not prime, sir. So
Yes, it's a composite term.
we gave it in the diagonal question, sir.
So I'm going to discuss. It's you have to prove it's always composite. So first thing, obviously the proof will not come to your mind. First, what we'll do, we'll check whether it's composite or not. That way the brain works. The brain supports for verification, means you'll substitute some values and try. But I'm asking to prove it. So first, if I put 2, say n is equal to 2, if I put it. So 2 to the power 4 plus 4 to the power 2. So 16, 2 to the power 4, all of you know 16. 4 square is also 16. So 16 plus 16 is 32. So 32 is obviously a composite number. The difference between composite and prime, in prime, the number itself and 1 are the factors. But in composite, you have other factors also. So if I check out for 3 for a moment, because you may have an intuition that if it is odd, there is a chance. But my dear, it's very simple. If you recall, so it says 81 plus how much? 64 is equal to 145. If the number ends by 5, it's divisible. Even, no need to check. Even plus even is every time even. So even number more than 2 is always composite. I repeat, there is only one prime number which is even, that is 2. Others are all odd. So in this case, even plus even is even. So it's not at all a prime when you are putting n as an even number. Yeah, for odd you can argue that. But the idea is to solve the problem, to prove the problem. Proving means for all values of n greater than 1, it should be a what called a prime number. Sorry, it should be a composite number. So how are you going to do? So we are going to take help from Sophie Germain identity. That's the if you recall what I'm going to do, correct? I treat this as okay for your simplicity. I'll write x to the power 4. Okay. Okay, fine. Let it be n to the power 4 plus 4 to the power n. Okay. So I'll consider it's like a square b square. So can I write 2 to the power 2n? So n square the whole square plus can I write 2 to the power n the whole square? Because power to the power gets multiplied, so it's 2n. 2 square is how much? 4. So we got a square plus b square. Okay. So a square plus b square. How can we write? So what is missing in the story? 2ab. That's what we learned in Sophie German. We know a square, we know b square. So 2 into n square into 2 to the power n. So this stuff you got it. So I need to subtract the same thing. So 2 into 2 to the power n is 2 to the power n plus 1 into n square. I hope everyone understood 2 into 2 to the power n is how much? 2 to the power n plus 1 and n square. So this. So n square plus 2 to the power n the whole square minus 2 to the power n. I need to write this as whole square. So I'm dividing by 2 into n, the whole square. So it is a square minus b square. So what can we write this as? N square. Yeah, I'll explain, Darshan. So n to the power 4 plus 4 to the power n. I am just trying to write this in terms of Sophie Germain. That is nothing but n square the whole square plus here 2 to the power 2n. Can I write 4 as 2 square? I hope you understand this. 4 as 2 square. The 4 can I write as 2 square whole to the power n. So it is 2 to the power 2n. I hope you understood. And then further, can I write 2n the whole square? So this is kind of a square plus b square. So it is, I am introducing, to make it into whole square, I need to introduce 2ab. I need to add 2ab and subtract 2ab. I need to add 2ab and subtract 2ab. I hope everyone agrees. So I am adding 2ab. So this is a square. This is b square. So this is 2ab. And I'm subtracting the 2ab. Isn't it? 2 into 2n is how much? 2 to the power n plus 1. So I'm subtracting 2 to the power n plus 1 into n square. I hope it's correct. So this is n square plus 2 to the power n the whole square. And this here, I need to write this term as whole square. So n square is there. Only we have a problem in n plus 1 this. So I wrote n plus 1 by 2 the whole square. I hope now you got it. Isn't it? Yes? 2 to the power n plus 1 by 2. If I bring the square this side, the power gets multiplied. So the 2 get cancelled. So n square. So it's like a square minus b square. And all of you learned what's the formula for a square minus b square. It is a plus b into a minus b. So n square plus 2n, 2 to the power n plus 1 by 2 into n, isn't it? N square plus 2 to the power n minus 2 to the power n plus 1 by 2 into n. Okay. So you may think that this 2 to the power n plus 1 by 2 is not an integer. Whenever factor means the product of that particular number should be an integer. Isn't it? You can't say that, the factor of 7 is 7 by 2 into 2. You can't say. That's wrong. You need to express this into two factors, two integers. So here also integer should be there. So the problem comes n plus 1 by 2. Okay. N can be even or odd. That's the idea comes. N can be either even or n can be odd. This is okay. If it is even, earlier itself in the beginning, I told if it is even plus even is even plus even is even. Even plus even is even. I repeat again so that you understand. If n is even, this power is even to the power 4 is even, and 4 to the power even is even. So even plus even is even. So there is no chance of prime number. There is no chance of prime number. So someone replies something. I'll check out. Oh, fine. So I'll continue. So if n is even, I'll write over here. If n is even, okay, n to the power 4 plus 4 to the power n will be even. So it's not a prime number. It's a composite number. Now comes when n is odd. When n is odd. If it is odd, n plus 1 will be what? Odd plus 1 is? Yes, everyone? Odd plus 1? Odd plus 1 is what? Even. So n plus 1 will be even. Okay. So followed by, okay, n plus 1 by 2, which will be even by 2. So it's divisible. It can be odd or even, we don't bother, but it's an integer. It's an integer. So we had a doubt that this will be an integer or not. So obviously we are bothered only when n is odd for this kind of expression. I repeat, if it is even, it's not a prime number, it's a composite number. If it is odd, okay, if it is odd, then 2 to the power n, n square plus 2 to the power n, 2 to the power n plus 1 by 2 into n square plus 2 to the power n minus 2 to the power n plus 1 by 2 into n. So this 2 will be an odd number. This 2 will be again an integer. And if it is integer, we are able to express as a product of two integers when n is odd. N is even, no issues. That is called trivial. Trivial means it's sure, it's bound to happen. When n was odd, we had a problem. So we could express this as a product of two terms. Please do it on your own. Please do it on your own. If you find difficulty, either you ask me or see the solution in the screen. But don't directly note down. It is a beautiful problem, came in RMO. I forgot the year. I'm going to discuss another tricky problem. So please, if you have understood, please reply yes. Otherwise, I'm going to repeat again. So I'll give you 5 minutes time to do on your own. Then if you have a doubt, you can reply me. Someone replies for the thing. Oh, yes, understood. Yeah, someone asked till what time? I started the class late, so give me some another 15-20 minutes.
Sure, it's okay, let's ask.
I hope all of you are able to do on your own. Please reply with yes. Few of you replied. Others, please do reply. If you have a doubt, you can say, I want to understand again. Oh, fine. Yes, someone replies. Yeah, I'll send the recording, sure. Okay. And others, if you have any doubt, please tell. Please raise your doubt by messaging. And I request everyone, obviously I'll send you the recording, but I have a suggestion. If you do at that particular moment, you understand better. So shall I move to next problem? Okay, I'm moving to the next one. Another beautiful problem is there, which I'm going to discuss right now. Okay. It's given 2 to the power 202 plus 202. This is a very big number. Obviously, you cannot find by using calculator. Students always try to find out calculator. If this number, this big number, okay, is divided by 2 to the power 101 plus 2 to the power 51 plus 1, what will be the remainder? Now it's your headache to solve the problem. I repeat, 2 to the power 2002, 202 plus 202 plus. This is not on the in the power. This is plus. And 2 to the power 101 plus 2 to the power 51. If you divide the number, this is the bigger one. You can make out because the power is huge. So by this one, what will be the remainder? This is the problem. All of you give a try. Again, Sophie Germain. There is nothing else you need to apply. You have to apply only Sophie Germain. I'll give you another 5 minutes time. Everyone, come on, come on. Come on, guys. Anyone? It requires Sophie Germain to solve it. Anyone? Shall I do it? Or you want me to wait for a couple of minutes? Please reply. Hello guys, shall I do it? Okay, fine. You need to apply Sophie Germain. You see how beautifully we'll apply Sophie Germain. So, how to apply is our headache, isn't it? Someone tells wait. Okay, I'll wait another 2-3 minutes. Anyone? Reply? You put it in Sophie German format. Put it in Sophie German. Hello? Oh yeah, obviously. But let me try. So let me give the solution so that you get, and I'll give you other questions also. But so see what I'm going to do. This kind of, this is 1 power 2002, and so this attracts the whole intention. The you see, this is like power. Half of the power is 101, isn't it? So kind of x to the power 4, this is x square, kind of that. So what I'm going to do, I'm going to write 2 to the power 2002 plus 1, because this will be very huge. You can't, this is not a perfect square 1. So 2 to the power, can I write 101 the whole square plus 1 square. So that is a square plus b square. I hope you understood why I took 202 and why I took 1. This why I took only 1, you could have wrote some 16 plus something. That also I'll tell you. You will be able to see it, why. So this is a square plus b square. So how much will come? Okay, I should write 2ab, 2 into 101 into 1, obviously, plus 1 square, okay, minus 2 into 2 to the power 101. So you get a square plus b square plus 2ab, that is 2 to the power 101 plus 1 the whole square. That is a plus b the whole square, everyone. That's what we were doing. And this, if you club 2 into 2 to the power 101, the power is 2 to the power 1. So 1 into 101, 1 plus 101 is 102. So 2 to the power how much? 102. Okay. Is equal to, can I write 2 to the power 101 plus 1? I want to write this as whole square. So 2 to the power 102. Okay. 102 is nothing but how much? 102 is 56 into 2 is 102. So kind of I can write 2 to the power 56 power 2, because power
56 into 2 is 112, sir.
Okay, so 53, 51.
51.
Oh, that's a printing mistake. Okay. So 51 the whole square. Is it okay? No. So a square minus b square is 2 to the power 101 plus 1 plus 2 to the power 51 into 2 to the power 101 plus 1 minus 2 to the power 51. Okay, fine. So this is the factorization for this. Why I took 1? Because now can you make out this particular thing, only 1 will come if you take this b square to be 1. I hope you understood. If you take b square to be 1, then only here 1 will come, otherwise. So this you need to forecast it. Okay. So now 2 to the power 202 plus 1. Can I write as, oh, not plus 1, it's given 202. Can I write as 2 to the power 202 plus 1 plus 201? So this can be factorized into 2. This can be factorized into 2, which we already did it. 101 plus 2 to the power 51 plus 1. I wrote this term. 2 to the power 101 plus 2 to the power 51 plus 1 into 2 to the power 101 minus 2 to the power 51 plus 1 plus 1. I hope everyone got it. So this particular number, now if you divide this, okay, that is 202 plus 202. If I divide the number, this get cancelled. Oh, so remaining is 201. Remaining is how much? Here was 201. So if I divide, this get cancelled. So remaining will be how much? 201. So the remainder is how much? 201. I hope all of you would have enjoyed this. Okay. So that's the use of Sophie Germain. Okay. So what I did it, the class is over today, and I'll post only 4 or 5 problems on Sophie Germain. Try out. Next class we'll discuss. Is it okay for everyone? Okay, fine. So make a note. I'll keep the camera on. And after 5 minutes, the class will get over. Okay, fine.